Okay, so to graph cotangent, remember cotangent is just the reciprocal of tangent, so it's cosine x over sine x. So with cotangent, we're going to have an x-intercept whenever cosine is 0, because the numerator will be 0. So that is whenever x is a multiple of pi over 2. That is an odd multiple of pi over 2, I mean to say. And so here you can see that cosine, wherever it's pi over 2 or 3 pi over 2 or negative 3 pi over 2 or whatever, an odd multiple of pi over 2, that's when it hits the x-axis. And so that's when cotangent is going to be 0. So it will cross the x-axis at those points. Then we know that the graph will have an asymptote whenever sine is 0, since sine is in the denominator. And so the asymptotes are going to be where this red graph sine is 0, so right there. And then we also know that when sine and cosine are both positive, cotangent will be positive. When sine and cosine are both negative, cotangent will be positive. But when they are opposite signs, that is where cotangent is going to be negative. So you also know you're always going to get, for cotangent, you're going to get 1 or negative 1, depending on what quadrant you're in. If you have any kind of angle whose reference angle is pi over 4. So that's also a good thing to know if you want to draw your graph more accurately. Okay, so if we wanted to graph f of x equals 3 tangent pi over 4 times x, if we go back and look at the basic tangent function, we have it passes through 0, 0, and then on either side of the y-axis, it has asymptotes that are an equal distance away from the y-axis. And since the period of tangent is pi, you go pi over 2 to the right and pi over 2 to the left, and that's where that graph is located. It's right in the middle. The 0 of the graph is right in the middle of the two asymptotes. There's an asymptote pi over 2 away on the right and another asymptote pi over 2 away on the left. So that is what we know about the basic tangent function. It goes through 0, 0. It has asymptotes at equal distances on either side, pi over 2 away, since the period is pi. And so we're just going to see how this function differs from that. So first of all, we know that it has not shifted horizontally or vertically. Nothing has been added to the function. Nothing's been added to x, the argument of tangent. So, and also it's not negative, so it's not reflected over any axes. So we know that it's going to go through 0, 0, because that's what the tangent function does. And it hasn't been scooted to the left or right or up or down. So it's still going to have that 0 at 0. So the period is changed because pi over 4 has been multiplied by x. So just like we do with sine and cosine, we take that coefficient and we say pi over that coefficient is our new period. So pi divided by pi over 4 is 4. So the vertical asymptotes are going to be at negative 2 and 2 because we know that that 0, 0 is right in the middle of the two asymptotes. And since the period now is 4, that means half of it's going to be on one side and half of it's going to be on the other side. So the curve is going to happen inside those two asymptotes. So if we just pick a couple of points, it might help us understand what's going on here a little better. So say we have our x and our f of x. If x is 1, then you're going to have 3 tangent pi over 4. And tangent pi over 4 is 1, so 3 times 1 is 3. So the point 1, 3 is going to be on this graph. So you put in negative 1 for x. Put in negative 1, tangent of negative pi over 4 is negative, so it's going to be negative 3. So at negative 1, you're going to be down here at negative 3. So that vertical stretch of 3 is making that happen. So we'll have the points 1, 3 and 1, negative 3, and then you can just draw your tangent the way it normally looks between the asymptotes, and it'll look like that. This is not a super, you don't have to be super accurate, you just have to make sure it's located in the right place and that the period is correct. All right, for the graph of cotangent, so first of all, let's remember what the basic cotangent function looks like. It has an asymptote at the y-axis. So it has an asymptote right there, not a 0. And it has zeros at equal distances away, pi over 2 away on each side because its period is pi as well. There's no period change. Nothing's being multiplied by x. There's no reflection. It's not a negative cotangent. There is a phase shift, pi over 4 to the left. So we need to move everything to the left, pi over 4. So now we can see where we are, but we also have to add 2. We have to do a vertical translation up, 2 spaces up. So here's where we are, and we will just draw it the way we would draw it if it was a basic cotangent function. So to fill in some more information, remember that the period is pi. So that asymptote right there, there's going to be another asymptote pi away from that one. So that one's at negative pi over 4. So there's going to be another one at 3 pi over 4, and then another one at 7 pi over 4, and another one at negative 5 pi over 4. So those are the asymptotes. And then you've got your zeros. You've got one at pi over 4, so there'll be another 0 at 5 pi over 4, and so on, because they're all going to be pi away from each other because this function has a period of pi, which means every pi radians, it does the exact same thing. If you look at, say, you put in 0 for x. So if x is 0, if you put in 0, you've got cotangent pi over 4 plus 2. So that's 1 plus 2, which is 3. So when x is 0, you're going to have a point through 3 right there, 0, 3. And that same point is going to show up every pi radians. So you can pick a few points, see what that looks like, sketch it. You don't have to make it perfect. Just want to make sure you know where it's located and what it looks like, and that it's in the right orientation.